Hello, and welcome to this talk on critical thinking with UML diagramming and prompt engineering. This is a usability project that focuses on workflow analysis. So this project is part of the Education B cluster research, and this is part of the Technical Communication Lab project that is currently being undertaken for 2024-2025. And this is the University of Aizu, Japan. Okay, so let's get started here. This is a very crucial topic because we are not only talking about critical thinking. In language studies, critical thinking has been around for a long time now. But what is new is incorporating UML diagramming and prompt engineering as part of critical thinking. So that's the new part. And prompt engineering is even newer. And we have a lot of questions about when we have something like ChatGPT, how is it going to influence our language learning abilities and the way we teach language and how the students grasp it. But when it comes to critical thinking, it opens a lot of new opportunities, and that's what we will be focusing on as part of this project. So in this case, both usability engineering and prompt engineering are the key aspects, coupled with the fact that UML diagramming is a very strong visualization tool that's been around for a long time in software engineering for construction and deconstruction of systems and understanding how the system works, how the structure works, and so on. So we will be focusing on the workflow analysis. So let's move on from here. So we focus on project-based language learning, and workflow analysis is a part of project-based language learning. So when we look at project-based language learning, we pay a lot of attention to the projects that are handled outside the classroom, like going to local businesses, talking to people who are in some kind of job, interviewing them, and so on, and coming back in the classroom with that kind of an assessment. The problem seems to be that in such cases, for such kind of projects, we are not actually exactly able to measure how the students have interacted. So there's no systematic process in place, so to say, in terms of when we think about software engineering and when we think about what UML diagramming is. So in some sense, many people will say it is structured because the students are going to make a questionnaire, then going to interview people in a very structured way. But the interaction, the workflow, so to say, the interaction between the student and the person they were interviewing is not very systematic. What has the person responded to? What kind of questions are asked? What kind of second layer questioning was asked? What kind of response did the student get, and how he responded back and forth? So this back and forth interaction is not well measured. We don't know exactly what's going on. But when we focus on something like workflow analysis for online interactions, something like online trading, e-commerce, tax filing, software installation kind of activities, then we can measure. So that there are standard procedures in usability testing scenario that allows us to measure the workflow scenario in a very systematic way. So this project that we are going to deal with is a add-on to that kind of systematic interaction. So we are taking it to another level using prompt engineering so that the students exactly understand how this is unfolding and what is the end goal and how that end goal has to be reached in terms of assessing the interaction, in terms of asking questions during the interaction, and so on, and getting a response. And then this iterative process is very crucial to usability engineering. And ever since ChatGPT, something like the large language models have come into the picture, we are using it in a very systematic way, both in software engineering. And this study is about showing you how there's a potential even for language professionals, especially in the field of technical communication, to use it. In our cases, for the courses that are offered in the Center for Language Research, there are plenty of opportunity to use this kind of a system, this kind of an approach, whichever class you are teaching, and customize it for your context. There's a lot of opportunity to do that, and we can talk about that after the class. Okay, so the next thing is unified modeling, language diagramming, and critical thinking. So, when we talk about critical thinking and when we are talking about UML diagramming, there are many aspects to it. The critical thinking incorporates many aspects when UML diagramming is part of the critical thinking process. So, for example, it really helps to improve the analytical skills because of the structured information processing that happens. And that's something that we will look into very soon. It promotes structured thinking. Then there's something like abstraction and generalization, problem solving skills, communication in the group, and the collaboration that happens. Okay, back and forth collaboration that happens, even that can be systematized. Evaluation and iteration, a feedback, a process of feedback, then improving the process iteratively, not in one go. And we'll see how that happens with few shot prompting. So anyways, the process seems to be, uh, especially for procedural information processing, the process seems to be decomposition of complex systems. Okay, you understand each part one at a time, and you see how they're related to each other and how the information flows, how the activities flows, how the dependency between these clusters flow. So that's what they're calling the decomposition of complex systems, and that relates to the dependencies and relationships that are embedded in the process. So when we talk about critical thinking and UML diagramming, these are the factors that plays a large role. And this kind of things like analytical skills, structured thinking, abstraction and generalization, problem solving skills, collaboration in teams, evaluation and iteration, all these things automatically happen. You don't really have to focus on one at a time each. So these are automatically embedded in the process when you use something like prompt engineering and UML diagramming for structured procedural information processing. And my area is procedural information processing. So all the projects that I do are talk about physical processes, whether it's online or offline. Okay. So, so basically, as I said, we are talking about evaluating user interactions with the interface. Okay, so for example, online trading, tax filing, e-commerce, etc. And when we are able to identify the typical workflow with usability testing, it helps us to develop LLM prompts to guide the user towards developing UML diagrams. Okay, so we'll see how prompts can help you develop UML diagrams, and based on the UML diagram that's already made, how can you dissect the process towards text construction? So it can work both ways. So basically, it helps with clarifying complex ideas like visualization of concepts, identifying relationships, encouraging thinking like cause and effect, conditional thinking. Strategic problem solving is also part of it, something like hypothesis, resource planning, understanding dependencies and relationships, precision and completeness, whether the process is complete or whether there are other dependencies that has been ignored. As I said, it's an iterative process, so you cannot get everything in one go. Then structured thinking, and then documenting the process. That's another thing that we are not going to talk about right now, but that's part of another layer of information embeddedness that is incorporated based on the LLM prompts that are generated based on the user interactions, preliminary user interactions. So workflow as a task. So as a user, when you log in for doing anything, then for example, in this case, it's shown on the left-hand side, you see login, browse, add to cart, payment processing, and the workflow analysis steps. You're constantly evaluating yourself. You're constantly grading yourself, so to say. You're providing feedback to yourselves. So you analyze the user task. It can be done by the usability expert, of course, but it can also be done by the user who are actually undergoing the workflow. So you analyze user tasks and you identify the pain points. What has been the problem so far that you identified in the interaction? Okay, what kind of mistakes you committed? How did you get back from those mistakes? How did you get back on the right track? How much time you spent doing something which was not really required to be done at that point in time. So something is important, something is unimportant. Something is important at one point of time, something is unimportant at another point of time. So it's not about something you don't need, it's about the priority of the task. So all these issues are embedded in analyzing user tasks and pain points. And based on this information, you optimize the navigation process. So that's how it works. You provide feedback to each other. But in other workflow systems, like when you go out for other project-based language learning analysis and so on, exchanges, you don't really do that. You complete the task without any feedback, without any iteration, without any evaluation at that point in time. And retrospectively, you look at as to what you could have done better. But by that time, you're not really measuring exactly the problems that happened when the thing was unfolding. All right. So there are many kinds of UML diagrams. So for example, the class diagram, the use case diagram, the sequence diagram, the activity diagram, each has its merit. And you have to know when to use each of these. So for example, when you're using something like class diagram, you want to see who are the agents who are involved in the process and the relationships and how they are related to each other. Okay, so for example, a customer can hold multiple accounts. An account can have multiple transactions. Okay, transactions may involve association with several accounts at the same time. Okay, so for example, I'm talking about the banking system. So whatever examples I'm going to give you right now are based on trading and banking. So that's what I looked at because that's my area of study. My area of study has always been economics and econometrics, and also look at the human-computer interaction. Now, a very important topic these days is econ linguistics and then big data analysis using economics and so on. So these things are now intertwined. These are not completely mutually exclusive subjects these days. So for example, when you study marketing, these days you don't study marketing only, you study marketing analytics and big data and AI and so on. So anyways, that's besides the point. But what I'm trying to say here is that the understanding the relationships in different aspects, why something is happening, how this it could have been improved. So the class diagram is a very basic one. When you go to the use case diagram, you look at the actors, the use cases, what kind of tasks are the users actually doing. So for example, deposit funds, withdrawing funds, transfer money, view account balance. So this is an example from the banking system. Okay, there are many other examples. Whichever task you pick, you will get that set of instructions, that set of tasks for that particular task. Associations. Customer has access to view account balance, transfer money, withdraw funds. So these are associations. So a sequence diagram, you talk about the sequence of activities. So customer initiates a transfer request, then what happens? So for example, if you're in the ATM, how do you interact with the ATM step by step? What are the things you do? So that's kind of a sequence diagram. Activity diagram is uh, activity diagram is can be similar to sequence diagram but may not be, because sequence diagram talks about kind of a standard sequence, standard activity that's done. An activity diagram is more fluid because activity diagram can show you exactly what's being done, not what should be done, but what is generally done. So activity diagram and sequence diagram are not exactly the same thing. Okay, the activity diagram basically talks about the flow, and the flow may not follow a conventional method. So on the right-hand side, you see that in UML diagram, you have two kinds of UML diagrams. So basically, you have the structural diagrams and the behavioral diagrams. The structural diagrams are more standardized. Okay, the structural diagram talks about the systems, the descriptive processes, and behavioral diagrams are more procedural. Behavioral diagrams are more dynamic. It's more fluid. It's more based on the context of use and how it can change based on the activity that needs to be done, the context that needs to be done, the meaning that comes out of the transaction, and meaning that is intended, and so on and so forth. So I don't want to go very deep into it because then we get into the semantic side of things when we start talking about the behavioral diagrams. So let's keep it at that. So one side is the structural diagram, the other side is the behavioral diagram. And based on our needs, based on our requirements for a class or particular what we are trying to achieve, we can choose either of them. Okay. So basically, it steps in the process. So for each UML diagram type, you can start. So this is kind of a standard method that can be followed when you are using UML diagrams, starting from a particular media. A media can be a text, a video, an interactive interaction online. So you can start from there and then go towards the very end, towards the UML diagram creation. So we start with video tutorial. So investing guidance from Investopedia, because in this case, as I said, I've used the trading platform Investopedia, and I've used the Investopedia simulator, the trading simulator. And the reason I used it is because it's very fluid, it's very volatile, it's very dynamic. So things can change anytime, and the reasonings will change based on. So, for example, you have a price chart. Okay, you see a price chart in Investopedia simulator, and you have an opening price for a share or a security. You have an opening price, you have a closing price. Then you have the highest price for the day and the lowest price for the day. So you have these four things for on any given day, and how you would react will depend on whether you are intraday trader or a short-term trader or a long-term trader. Okay, so let's not get into that. The point is very simple. The point is that you can start with any media, and the reason I use the Investopedia is because it's, as I said, it's very fluid, and you can have lots of opportunities to draw different kinds of UML diagrams and create your own context based on the reason why a price structure changed. So anyways, you start with something like a video tutorial, okay? Investing guidance from Investopedia. Then you go into a reading and content identification. So the video and the reading content must match, and you do a quiz and try to understand. So the first two stages are an attempt to understand the content area. And then you start with the website interaction, website analysis, user interaction pattern. You go and evaluate what you have done, why you have done that, you take notes, and so on and so forth. Okay, based on this kind of an interaction and understanding of how you have done it, why you have done something, you design a concept map. Okay, and let's say it's a free concept map. We are not going to get into the specifics of what type of concept map right now. Let's have the opportunity to draw a free concept map, a free flow concept map. A concept map draft one, layer one, you prompt is provided. So you can go into, so based on the website interaction, if you put what you have done, the chat GPT will generate prompts for you. And once they generate prompts for you to draw a concept map, you can start drawing a concept map based on those prompts. And you can have three drafts of those based on improvements, based on gradual improvements in the prompts, gradual complexity increasing with the passing of each prompt. Okay, so you can go from concept map 1 to concept map draft 3, and then you go into the UML diagramming. Based on that, you can ask ChatGPT to create the plant UML. See, the point is, of course, these are computer science students, but from a language perspective, the idea is not to teach them the programming side of things, but to create the prompt and create the response iteratively in a way that will lead to the creation of the exact prompt that you need for Python prompts. Either, I mean, the prompts will generate Python codes, or the prompts will generate the plant UML code. Okay, plant UML or git UML code. You can go to these platforms, or you can go to Mermaid Chart, and you can insert those codes, and the UML diagram will be generated, and you can match it with the concept map that you have drawn based on drafts. So the idea is how well, based on your interaction, you can create the prompts to explain a certain situation, a certain interaction, a certain task with a certain goal that needs to be completed. And you can do the UML drafting based on the codes in layers using something like ChatGPT. So nowadays it's not about doing something from scratch. Nowadays you have the codes, you have the text, you have the steps that is generated by artificial intelligence, the LLM models, and you basically evaluate it to see whether that's what you've done is the right thing. I mean, these days when software engineers are being interviewed, they're not asked to write codes. They're asked to evaluate and analyze whether the code that has been given to them makes sense or not. Okay, whether they can see through the mistakes, they can see through the gap. This is a similar ideology. This is a similar concept that I'm using right now. Okay, so that, and then based on the UML draft, you ask the students to create a text explanation generation based on the UML diagram which has been created. And the UML diagram, as I said, has been matched with the concept map. And then you compare the self-generated draft with the image interpretation draft generated by ChatGPT Image Analyzer. Okay, so basically then you create your own text based on the UML draft, you create your own text to write about the interaction, and then you upload the image of the UML draft and ask them to give a text response, and you see whether the text response generated by the LLM model matches the text that you have created, the student has created. Okay, so that's how the thing should flow. So it should flow from self-generated, manually created concept map towards UML diagramming, from UML diagramming going back to the text generation, and then using an image analyzer to match whether what the image analyzer is giving you as an output matches with the text explanation, matches with the UML diagram. Okay. So this is basically a mapping concept comprehension based on website interaction. So you can create different kinds of prompts. You can create simple prompts, moderate prompts, intermediate prompts, and these prompts are being created based on the user interaction that is generally done by a novice investor, a moderately learned investor, and an expert investor. So this is pretty structured. We know what a novice investor does. We know what a moderately learned investor does, and we know what an expert investor will likely do. And the prompts are being generated based on that. So this is based on established usability studies on trading indicators that are already been consulted in this, and the prompts are generated based on that. So you have an objective, and then you know that what a simple prompt can do, what kind of a website interaction is expected based on a simple prompt. You have the follow-up concept clarification based on that. So simple prompt talks about what is stock trading, for example. The intermediate prompt talks about explain the difference between day trading and long-term investing in stocks. Okay, and then you are learning based on that, and you have expected interactions. This is what you're expected to do when you're talking about concepts. Then we go further if we need more based on the context. Then from intermediate prompts, we go more towards advanced prompting, expert prompting, and highly specialized promptings, and the tasks will get more complex accordingly. And you have the expected interactions already put down because we already know. So when you put this kind of information in the LLM, the LLM is going to generate exactly what are the expected website interactions. And this has been matched to create this table. This has been matched with the moderate investor and the low grade investor, the basic investor and the expert investor. And then this table has been established based on that. Now, mapping concept comprehension based on website interaction. Now you have matched your prompts to the expected website interaction. Now is the time to match the prompts to the UML diagram that's going to be created based on that. So if it's a simple prompt, you're more towards the class diagram because you're identifying the agents, you're identifying the attributes of the agents, and then you're identifying the basic actions. So that goes on towards the simple class diagram. Then as you move from the moderate, intermediate to the expert ones, you move towards the activity diagram, the use case diagram, the sequence diagram, the state diagrams, and so on. So we did two things until now. The first one is we matched the prompt type, the grade of the prompt to the expected website interaction. And then we are matching the grades of the prompts to the UML diagram type that's been created. So we have done these two things now. All right, so that helps us understand exactly what to write for each prompt, exactly what is expected at each level in terms of the website interaction, and what are we going to draw? What is our end product in terms of structuring the information in as a UML diagram? So how UML diagrams can clarify miscommunication. This is something important to understand. If it's a state diagram, if it's a component diagram, you see what I have done here. Here, this is a minimal queue. So this has to be a layered processing. As I said, this is iterative processing. So you've provided a minimal queue here in terms of map out different states a user can experience, such as exploring investments, selecting savings, reviewing tasks along with transition based on our feedback. This is the minimum. This is the starting point. You see what the students can do based on this explanation. You give them a model of the state diagram, okay, a general model of the state diagram, and see what students can do based on the state diagram. What are the initial steps? Now, this may come out to be insufficient. Then you provide them with the initial steps. Okay, in an initial step, exploring investment, the user can browse and select. So you give them the interaction. All right. So based on this interaction, the students can write down, can create a very solid explanation of what are the things that are expected from a state diagram. And then when you insert it into the LLM model, the LLM model is going to create a nice flow of UML codes for the plant UML diagram or the Git UML and so on, and also Python codes also. And then this is an example of a component diagram. You have the user interface, the portfolio selection, the risk assessment, the portfolio comparison. So portfolio comparison is very important because you need to see the different aspects of what various kinds of investors will do, and you should be able to compare it with one another. So that's what the component diagram does. It models the app's components and showing how each contributes to risk reward communication. So this is the component diagram is basically used not for the investor type, but to see how the different features of the app can play a role in analyzing how the user will interact with the system. Okay, so this is basically turns out to be a study in interaction design. Okay, and here you see the instruction steps. These are basic text instruction steps. Now, these steps are much better than these steps. Okay, these are very preliminary steps, and you have to complement it with these kinds of very structured information towards building a narrative that will lead to the creation of the codes for the UML. Now, so what you see here is basically enough steps that will lead you towards creating a diagram in using Creately, a software where you're doing a manual concept mapping diagram. Although they are calling it a UML class diagram, but basically you are using the template, the blank template in Creately, and you're trying to fill it up with information that looks like a UML diagram. So it's not that you are generating the concept map from scratch, but based on an already established template where you're filling in the information, which is also a great activity to do because you're providing them the structure so you can guess what's going to happen, what positions are going to be filled in each hierarchy, and you're filling them in, and you know what to fill in by that time. This is an example of layered prompting. So first prompt, second prompt, third prompt, helping the reader to get a response to this and gradually create the drawing in Creately. Okay, gradually create the drawing in Creately, gradually creating the text that will lead to the plant UML coding and so on. And you see there are the high risk investor. You're doing this for a high risk investor. This is a low risk investor. This is overall risk and reward communication. So you're creating the prompt. So this is actually similar to what you have done here. So the component diagram, okay, you are trying to identify the features of the map, the exact map, how it's going to play out, the feature of the interface, the Investopedia simulator, how it's going to play out. These are instructions that can be complemented with UML diagrams of this type. These are minimal UML diagrams. It tells you what should go into each kind of block. So for example, you have the investment portfolio, then you have the growth investment, stable investment, and you know which kind of investor will go for which kind of portfolio. And based on these steps, you can create enough text and ask ChatGPT to generate the codes accordingly, which leads you to a robust UML diagramming. This is kind of a minimal UML diagramming, okay? Because these are based on the codes, not actually the text. This does not help you understand the activities and the flow. So this is not about the flow. This is about what goes into each portfolio. But you can turn this into a flow by using this as an intermediate step coupled with these text steps which are already been outlined here. Okay, so and these are responses to the layered prompting. So the first prompt, second prompt, third prompt, these are responses to the layered prompting here. Okay, and as I said, when you provide these responses, the student construct, deconstruct, construct, deconstruct. So they go on improving in an iterative way the UML diagramming from text, moving on towards the UML diagramming. This is the end result. This is the outcome that you're probably expecting from each of these cases. Okay, so this is a state diagram, this is an activity diagram, this is also a state diagram, use case diagram. Sometimes it may so happen that based on the information, you may feel more comfortable to do a little bit different in terms of what diagrams you prefer. Okay. But if you are given a particular type of diagram, that's also another way of doing the assignment. If you say you give a series of prompts and then you say that you have to draw an activity diagram based on that, your questioning will change. But if you're asked to do a use case diagram, you will not ask the same set of questions as you would ask for an activity diagram. So it depends. So this entire model stands on your ability to query based on the series of prompts that you are being generated, series of cues that you have been generated, and the responses. So this is a very granular way of constructing a UML diagram. And you can get a very holistic, a very comprehensive UML diagram because you're using prompt engineering. Okay. Okay, so this is the criteria. If you have to use a rubric towards designing a few short prompts, because few short prompts goes from a simple prompt to the intermediate, moderate, intermediate, advanced, expert, and highly specialized prompts. If you do that, how would you know that this can stand tall? This is comprehensive. This is enough explanation. So you have to generate the prompts based on these criteria: clarity, relevance, progression, depth, and response specificity. Okay, so that if you ask the students to generate such prompts based on their interaction with the interface in a gradual fashion, then you have to measure it accordingly. You have to ask them in terms of clarity. What do they think about the simple prompt? Have they been able to use straightforward language defining basic terms? So basically, as I said, from authoring, this is going more towards evaluation. And this is a rubric that the instructors can use to judge whether a prompt suffices, serves the purpose, or you can also give it to the students to judge whether their generation of their creation of the prompts satisfies these criteria. Okay, so that's how it goes. This is about the UML diagram types. These are UML diagram types, and when you are doing it in an iterative fashion, these are iteration one. So you have the foundational prompts, the expanded details, the comprehensive specificity, the advanced complexity. So these are different kinds of prompts which are being generated based on the UML diagram type. Okay. This is very helpful because sometimes you will not know for which activity diagram or which type of diagram, which type of UML diagram, how to start with the prompting and how to go in layers. Okay, so this kind of a model, which is based on the testing of the interface and knowing what kind of prompts is going to, what kind of information is needed based on the interaction with the interface, you will know which kind of prompts should be generated. So this is the UML diagram type based on the prompts, and these are iterations. How do you improve from simple prompts to very complex prompts, advanced complexity? So here you're asking for a class diagram, create classes for basic trading entities like stock, trader. But here in advanced complexity, you are saying define relationships between multiple classes like portfolio and order. Okay, this is definitely much more comprehensive. You need much more comprehensive knowledge than creating the class, which are identifying simple agents who are doing it. Okay, and here you're adding attributes. So you have a bank account, you have a savings account, you have an investing account, you have a current account, what is the name of that account, and so on. So that's the attributes kind of things. So anyways, these are the different kinds of diagrams, and you can improve, you can help the student improve on the prompts on a particular context, whatever the context is. In our case, it's Investopedia context, finance concept is the context, but in other cases, you can use other contexts and just customize your prompt in layers based on such iteration. Okay, this is a step-by-step guide on drawing a UML diagram for individual prompts, and this is for a class diagram. So you see step 1, 2, 3, 4, 5, 6, and you have the prompts, you have the actions, you have the results, and you have the goals. Okay, so this is also another way you can improve on the prompts when you know that you're working on a certain kind of UML class diagram, a certain kind of diagram. So if you have to do this for an activity diagram, you can generate a prompt layering like this for the activity diagram. Okay, so when you have a something like this, and when you make students work through something like this, it gives students tremendous insight into what needs to be done. They understand very well what needs to be done rather than authoring thing from scratch, where it can flow like the based on the information you have, they just create a diagramming structure. They are not very deep into understanding the questions. They are not very deep into understanding exactly what kind of activity was undertaken and why it was undertaken, what should have been done and what was done. Okay, so these types of things are more prominent when you are more into the evaluation side of things rather than the authoring side of things. And this is basically what the prompts are doing here. Okay. Okay, and this is a criteria. So for this is a rubric for constructing a full text paragraph based on a UML diagram. So you already have a UML diagram and you want to write it down in terms of a text as to exactly what happens, what's being talked about. So this is the criteria that you will follow if you have to do that. Okay, this is already, so all these methods that are applicable in any technical communication classroom has already been tested, and we already ran pilot tests for each of these things, and then we has come to the conclusion that this is the method that's going to be more more applicable to the context for Investopedia in our case. And I'm working on the Department of Finance in the University of Western Macedonia, Greece, for this project. They're very interested in the Department of Finance in structuring user interfaces for finance. And they look at many other things like blockchains and everything and trading platforms. And in this case, we categorically focused on Investopedia because Investopedia is kind of a very standard platform that's being used. If this works with Investopedia, this is likely to be likely to work for other platforms as well. Okay, and this is based on dynamic actions. So if you have dynamic actions like a trader logs into account, what kind of for each of these things that you're trying to show, what kind of diagrams would you draw? Now, see, in many of these dynamic actions, these dynamic actions do not happen in isolation. Many actions can happen in sequence. And so what I'm trying to say here is that multiple UML diagrams can be drawn simultaneously with this based on these dynamic actions that have been talked about here. So you see, for many of these sequence diagram, activity diagram are kind of, there are so many of these, right? And some of these dynamic actions, so many of these dynamic actions follows from one another. So it's not that you do one and you stop. Okay, you can show many of these in terms of multiple UML diagrams being drawn or combined together into one UML diagram. But you can also do it as separate actions also. You can also do it in terms of individual actions, which is fine, but it can also be combined because that's the workflow. That's how generally it's going to flow. But here, what I'm saying is that inside one single dynamic actions, there can be multiple actions. There will be multiple actions, which are not only not activities, these are operations. Operations are not as conscious as activities or events. Okay, so that's how you have to look at things. Okay, this is explaining a price chart. I'm not going to go very deep into this, but this is trying to show that this is an AI generated image, and this is just trying to show that when you click on a price chart, and this is one example. When you click on a price chart, it will show you the reason why you get a new high price, why you get a new low price in the trading market on that particular day. So the reason, as I said again, why it's used is because it's so volatile. Every new high or every new low has a different reason for that particular thing happening as compared to the other one. So this volatility and this interactive nature of things, or the reasons changing every time there's a new high and new low, this kind of things makes it so very interesting in terms of the workflow. and the interface can actually tell you why this is happening and what you need to do as an investor. If you are a risk-prone investor, you will react in one way. But if you're a risk-averse investor, your reaction might totally change. You may go more into research. A risk-prone investor may go more into understanding what are the stocks that has performed well over that period of time. So this interactive back and forth nature of information flow makes it so very interesting, and generating the prompts to create the interface of that nature makes it so very interesting. So this is a decision tree for trading stock based on price movement insights. So this is a starting point. You have a new high or a low, and then based on what kind of an investor you are, you either check the market sentiment or you check the financial performance. Then you evaluate your trading options or you assess the risk, what you have, and then you take action. Either you buy or you sell. So anyway, so this is one way to look at things. So this is not exactly a UML diagram. This is more like a decision tree or a concept map. But it helps you to draw the UML diagram in an iterative way. Okay, this decision tree itself will tell you what kind of interactions could be designed so that any kind of investor, whether it's a risk-averse investor, risk-prone investor, moderately risk-averse or risk-prone investor, will react accordingly. Okay. Okay, these are things that I showed you a while back. These are minimal cues, and these are actually showing complementary to the text, minimal text that has been shown. These are UML diagrams as well, and you can combine these to create more actions in a text flow and generate the plant UML codes or the Git UML codes based on that. Similar things, these are activity diagrams and sequence diagrams for a low-risk individual. The first one is an activity diagram, which is quite comprehensively done. And the second one is a sequence diagram, which shows you the flow of activities, the flow of actions that has been undertaken by a typical user. Okay, but it will change when you move from a low risk individual to a high risk individual to a moderate individual to an investor to a professional investor to an investor, an investing consultant, and so on. And this is a UML diagram based on layers of LLM prompts. This is very comprehensive. The students can have this based on their interaction, based on their understanding of the Investopedia simulator. They can create the text. They can generate the text that will create other pieces, other structured clusters of concept maps or clusters of UML diagrams based on this one single comprehensive UML diagram, which is more like a state diagram. This is another interesting way to look at things. You can measure, the students can actually measure the user interaction patterns and identify the high frequency actions based on this kind of bar chart or regression analysis of the usage versus the time spent on Investopedia features, and then draw a state diagram based on that. So you can see from there, you can see based on the user interaction patterns, you can actually create a structure for how the interface should be drawn. Okay, so that's what they're showing you on the right-hand side. On the left-hand side, you actually ran a usability test to see how investor reacts, how the investor interacts with the interface, and which pages they click on, how much time they spend, what are the errors they do. If you're a risk-prone investor, how do you interact? If you're a moderate risk investor, how do you interact versus a high risk, and so on. And how do they interact with the cell phone app versus if they're on a desktop? So the device, the input also is a big thing. So for example, if they're into text, from text, where do they move? If they are watching a video, from the video, where do they move? So there are different kinds of interactions that you can have a free flow and try and understand their interaction patterns, and based on that you can draw state diagram like this, the one you see on the right, to understand exactly how the user is going to react, or are they going to go back to being idle, or they're going to get more active, research more, invest more, and so on. Okay. And this is an investor-video interaction with the LLM prompt. So you create a story. You can start by creating a story. So for example, in this case, the Jane, a finance enthusiast, you create a story and you give the user layers of information. Okay, this can be an in-class activity, layers of information, and you let students build on their text based on these identification of these features: actors, key attributes, actions, structuring the extracted information, and so on. And once they comprehensively write the story, ask them to create a concept map. From the concept map, they can create a Plant UML code with the help of LLM and so on. Okay, so you can provide the information in layers. So it's similar to what we saw in the tables a while back, right? So using layered prompts to extract information from a video, procedural video, and design a UML diagram. So if you watch a video on how to use an investor video simulator, and the first is the information extraction. What kind of information do you extract from the video? Break down major actions into several steps. Okay, so first is the what you see as the major actions, what you see as the peripheral marginal actions. Then you identify entities, attributes, and relationships. Four is define sequence flow for each action. Okay, and then extract the roles and the permissions. Okay, so what kind of roles do users have? What kind of roles a banker has? The bankers can be of several types. So those kinds of things. And then you finalize the UML diagram structure. And this can be done in many ways. This can be done in several layers of complexity. This is also an iterative process. Okay. So these are all very interesting assignments that can be done in the class using LLM prompts, evaluating the text and evaluating the diagram. Okay, you're just not writing it. So as I said, you're shifting from authoring more towards analysis. And this is the following the workflow trail. So when you are creating the diagram, take notes. Note taking based on video, text, and interactive video is very important. So you know the user role, you're an investor or you're a learner when you're working with Investor Video Simulator, and you have created this slowly and slowly and slowly in an iterative way based on several layers of prompts. And the teacher can actually judge what kind of prompting is going to be crucial in which layers. So the tables, if you look back on the table tells you exactly how the prompts could be structured. Okay, based on what criteria. So if you see the rubrics, if you see the interaction patterns, if you judge what type of UML diagram should the reader go for, then you can mix and match these things and shift between different media. You can move from text to video, video to text, from text to UML coding, from coding to the diagram, from the diagram back to the text. These kinds of interactions and the interaction with the website is going on as we speak and move between these other kinds of media like text to video, video to diagram, visualization, and so on. So in future, I would like to use Chatbase to create a chatbot for testing UML diagram construction. And there's a lot to be done in there, especially in terms of the feedback and assessment, because feedback and assessment is going to be layered and is based on the task complexity. So it's going to be a complicated process, but I'd like to try using that and learning how to combine Chatbase with external tools for diagram creation and evaluation, something like matching the task that has been done in Creately, Mermaid chart, Lucid chart, Plant UML codes, and see if it matches the cues, the text cues that has been provided to them. Right. So that's how I want to use a chatbot and see how interactive it can be. And these are some of the sources that I've used in prompt engineering and software engineering. Um, yeah, it really helped with understanding how the UML diagrams and how the usability tests could be structured in a layered way. We already, I'm already in the field of usability sciences, so I know how usability testing is done. But using prompt engineering was really an eye opener because of the granularized information blocks that could be created and how the tasks could be visualized and mixed and matched between different kinds of investors. So the context of application really helped when I was doing this for investing and trading, as opposed to some kind of task which is more static. So a more static task is going to be more simple to handle. So, but we can start from simple, of course, and move more towards tasks which are more dynamic, more volatile, which changes over time. The actions are not really static. And those kinds of activities that really puts up the challenge, and in terms of both the evaluation and the different kinds of layers and everything, and the feedback that's generated. Okay, thank you very much.